Welcome to cloudonaut Plus, your source for exclusive videos and online events for AWS professionals. My name is Michael Wittig, and today I'm going to introduce a new feature of the CloudFormation service. And this was actually asked for by the community, so thank you very much, Thomas, for asking this question. And the feature I'm going to talk about will help you to reuse CloudFormation templates. Or basically the question is, will this feature really help you to reuse CloudFormation templates, and what other approaches exist? So what's the feature I'm actually talking about? It is called CloudFormation Modules. So let's dive into the topic and see what you can expect from this video. So first, we will look into the motivation for this topic. So how can we reuse templates? Why should we do that? So that's one of the first aspects we're going to talk about. Then I will give you an introduction into CloudFormation modules. So how do they work? What are the prerequisites for using them? And what are the kind of goals behind this new feature? I also created a demo where we set up a VPC using modules that I created, and I will share the code with you so you can use that in your own projects or kind of use it as study material. Last but not least, we will talk about the good and the bad parts. As always, we don't only look into what this feature is kind of good at, we also look at all the limitations, the pitfalls, the problems. So that's the outline for today. So let's get started. So this is how a CloudFormation template looks like. So for example, this contains a typical web application. So to deploy a web application, you actually need a VPC, you need subnets, and I mean, the truth is you actually need a lot of more resources. You need route tables, you need associations, you might need a NAT gateway, you need access control list. So it's a whole list of resources only for the VPC. We put in also our database into the same template. So it's a database instance, it's a subnet group. I mean, there are a bunch of other resources that might be beneficial, like a security group. And then we have the auto-scaling group, we need a launch template, and we need the load balancer, the target group, the listener, and all kinds of stuff. All kind of added to the same template. And this is, I think, the first approach. This is also the approach that I took when I was getting started with CloudFormation. The problem here really is 1 week later, you want to launch a web application that is slightly different than this one. So how can you do it? So you copy the whole template and then you have two templates. Problem is you make a change to one template, you forget to kind of fix that problem in the other template as well. And now we have kind of chaos. So how can we avoid that? So one strategy is to split things up into multiple templates. For example, one good idea here could be to have a VPC template. So you can split out all the VPC related resources, put them into a single template, and then you create a template for your application. And this only contains the resources that are needed for the application. So for example, the database and the load balancer. But now the problem is, how do we get the VPC information into this template? And the answer is parameters. So for example, we need the VPC ID as a parameter. We might need the subnets as a list of strings or list of IDs. And so we can kind of combine the two templates together, but this requires manually wiring up those things, for example, in your deployment pipeline. So the problem with this approach is that the list of parameters can get really long. So, I mean, a VPC contains all kinds of things, not only the VPC ID and the subnet IDs. You might need additional information in your application stack, and then it grows and grows and grows. So there is another approach that kind of solves this problem of lots of parameters. So again, we have a template for our VPC, but this time we create a so-called output, and an output can be exported. So an export has to be it's basically key value pair information, and the key has to be uniquely identifiable in your account region. That's why usually you prefix the output with the stack name, which you can access in CloudFormation using the AWS stack name variable, and then you kind of append the key for this information. So for example, I append the VPC ID. Same works for subnets. So now we look into the app template. Here we only need a single parameter which references the stack name of the VPC stack. And then we can import those values that were exported by the other stack by using the import value function. And you see an example on the slide deck. So in this case, we have to combine import value with the substitution function. And then it gets a little bit ugly because we cannot use the short form twice. So we cannot write exclamation mark import value, exclamation mark sub. That's not going to work in CloudFormation. So we have to use the long form for import value. And then we apply the sub function and we kind of get access to the VPC ID. And this is the approach that we use in our AWS CloudFormation templates repository that is around for quite some time and used by many people. It works well, it's proven. The only problem with this approach is that an exported value is not allowed to change. So in the VPC stack, if you make an update to that stack, that will change the VPC ID, which is probably a super bad idea anyways, because it will recreate the whole environment. But that's not possible. An exported value is not allowed to change as soon as it is imported by a stack. So that's the only downside pitfall of this solution. But still, we see this working well in our templates, but keep in mind to only export stuff that you don't expect to change. So that's the two approaches that we have. And this is actually one of the approaches that I really like. It gets a little bit complicated in really big environments. So you have to be careful, make sure that everyone kind of follows the same approach. Everyone prefixes their stuff with the stack name. So otherwise it gets a little bit messy. But with this limitation in mind, it works very well. And it's proven and it's available for quite some time. So other approaches for reusing CloudFormation templates. There's a feature in CloudFormation called a nested stack. So the resource type is AWS CloudFormation stack. You can basically create a stack within a stack, and this can be nested. So there is lots of room for kind of reusability here, because each nested stack can be a template that you refer to that is already existing. So for example, you can have a database stack, you can have a VPC stack, you could have an alerting stack, all kinds of things. One of the examples is our CloudFormation Modules repository. So this contains lots of CloudFormation templates that you could easily integrate with each other using nested stacks. And the benefit of nested stacks is that you can again pass values between nested stacks by referring to the outputs of a stack. You can also use import value, export functionality as described before. So it really works well on top of the mechanism that I explained to you already. So we have other tools available to kind of solve this problem. One is the AWS CDK, the Cloud Development Kit. There's also tools like Troposphere, and there are a couple of other tools. Basically, those tools are preprocessors for CloudFormation. So they run some logic and they output CloudFormation templates. And therefore, you can, for example, achieve things like modularization, because the preprocessor itself takes care of the modules and it just kind of mixes everything together in the big template, and then CloudFormation will deploy that template. So CloudFormation is not involved at all in this modularization topic here. It's taken care of by a tool. So that's also an approach that works well in many situations. But what is actually now this new feature about? So what is CloudFormation Modules? It was kind of more or less silently dropped in November 2020. There's one blog post by AWS that is kind of weird. It misses a lot of pieces. It referenced CloudFormation resources that were not available at that time. So when I first read that blog post, I was very confused. I had no idea how to use that. They talked about lots of things that were not explained anywhere and not in the documentation. But now the documentation evolved, so we have more information. And since Thomas asked me to kind of explain this feature to all the subscribers, I looked again into the project. In essence, a module is a CloudFormation template. They sometimes call it fragment in the documentation, but it is nothing else than a CloudFormation template. Could be JSON or YAML, both versions or both formats work. There is a little helper tool called the CloudFormation CLI, which helps you to create such a module, or basically to publish it into, and this is the next feature, the CloudFormation registry. So a module has to be published to the registry. So that's a important thing to understand. So basically you upload kind of your file into the registry with some metadata. A module has a resource type, and it is structured like this. So you have organizational part, you have a service name part, then you have a name of the module part, and then it always ends with colon, module, all uppercase. So that's the convention. Don't ask me why they're choosing the all uppercase thing. So CloudFormation is completely Pascal cased. So there is nothing uppercase usually in CloudFormation, but module is. So just keep that in mind when you create the type of your module. Last piece here is that you can nest modules, but only up to 3 levels deep. So that's a limitation. Keep that in mind. So with CloudFormation stack, as a nested stacks, you could have like the deepness of your tree could be much larger. Here it is limited to 3 levels. So there's something to keep in mind. So don't create modules that are too fine granular so that you have to nest them more than 3 levels to kind of create the actual application. All right. So that's it. That's the theory. Time for a demo, I guess. That's always the easiest approach to show how something works. So I'm going to switch into my editor and then we will look at actual code. Here we are. This is the first template or fragment. The structure of such a project is always, it contains a fragments folder. And within that fragments folder, you have a single file and the name doesn't matter. And this file contains the CloudFormation template. And this is a very standard CloudFormation template. So it has a couple of parameters. So those are basically all the inputs into our module at the end. And you can use conditions as before. We have the resources block. And here I just create the subnet resource, for example. Then I create the route table. I connect the route table with the subnet. I create a route. I create a network access control list, a couple of entries. And then last but not least, I connect the access control list to the subnet. So this is done in the subnet template. The cool thing about this is here that if I later create a VPC in multiple availability zones, I can use the same module. So I will reuse that module to create all the subnets in the VPC. That's pretty cool. And this is where reusability is actually beneficial, where it helps you to have ensure that actually each subnet is exactly the same, except for the site range and the availability zone that it references to. But all the resources and all the configuration will be exactly the same because you will reuse this template or fragment in all of the subnets. So the question is, how does the VPC module look like? And in the VPC module, we again have a plain CloudFormation template. So we have only one parameter here. So I allow you to specify the class B of the CIDR range of the VPC. But this is just what I expose to the outside world. I mean, you could do whatever you wish here. I create a VPC resource. So this is where this is done. It doesn't really matter what it actually is about. The important piece here is that how I create a subnet. Because now I use this special type. And this is a module reference. So this creates a resource based on the module cloudonaut VPC subnet. And that's the module that I showed you before. And I do this again for the private subnet in A. I do it again for the public subnet in B. And again for the public subnet, the private subnet in B. So I always use my module. And the module is only kind of created once, but I use it 4 times here in my module. So this is already a demo of nested modules because the VPC itself is a module and it contains subnet modules. So that's pretty cool. And it also works as expected. So the question is now, okay, how can we get this into the registry? And this is where the CloudFormation CLI comes into play. So first, what I want to show you is how can you create such a module. So let's assume we will create a VPC with 3 availability zones. So the one that I showed you only runs in A and B. So now I want to create one that runs in 3 zones. So what I do is I run the cfn init command. So cfn is the CloudFormation command line tool. And now this starts a little wizard that asks me a couple of questions. So first, do I want to develop a resource or module? I want to develop a module. So we talked slightly about the resource approach in a blog post before. So when we talked about how you can extend CloudFormation, so that's where resources come into play. So with modules, we can only use existing resource types that are already there. With a resource, you can create your new resource type. So that's the difference here, but we are going to focus on the modules. So I will select M for module, And now we have to enter the type of our module. The service will be VPC, and I will call this, I think I called the other one 2 zone or 2 zones, maybe I call it 3 zones. Sublet, and it has to end with module. So that's just, oops, and this is also one of the things that annoys me a little bit here. You cannot really use that properly. Okay, 3 zones. So that's it. The CloudFormation CLI creates the structure of the project. So you could now start developing it. And if you look here into my editor, you will see there's this fragments folder where you can see this JSON dummy file. And I just deleted that and replaced it with something else. There's also a config file. This basically contains the type, and there's log file and stuff like this. That's not important. So CFN init is for creating a new module. So how can we actually upload a new module? So let me switch into the subnet folder. So this is where my subnet module lives. And I first run the CFN validate command. And this will do all kinds of things. So first it will extract the metadata out of our module. So basically it runs over the parameter section and kind of copies that into another JSON file. I got a lot of warnings here. I don't know why. I opened the issue in GitHub because this makes no sense. It tells me all kinds of template validation errors. And if I run CFN, let me switch into the folder. If I run CFN lint natively against the exact same template, I get 0 warnings. And what this CloudFormation CLI tool does, it basically uses also the CloudFormation linter, but for some reasons, I don't know, it messes things up. I see lots of warnings, but it's not a big problem, so it still works. Okay, so next step is to submit this module into the registry. So the command is cfn submit. This will take a couple of seconds, depends on how fast CloudFormation is with the registration. So let's quickly wait for that to complete. All right, the module is finally registered with CloudFormation. If you run this command for the first time, it takes a little bit longer because there's actually a CloudFormation stack created that contains an S3 bucket, KMS key, and a couple of things to actually upload this into your account. And from there, it is somehow transferred to CloudFormation. So for the first time, that will be a little bit slower. I will do the exact same steps in the VPC module. So I have to run cfn validate. And then I run the submit command. So let's do that. And again, this will take a little bit of time until CloudFormation is happy and registered this type for us. In the meantime, we are going to look into the CloudFormation console and see how all of that looks like there. So this is the CloudFormation console, and on the left you will find the CloudFormation registry where you can click on modules, and here you now can see that I uploaded 2 modules, the subnet module and the 2 zones module. So that's exactly kind of reflects what we did before. So what I'm going to do now is I'm going to deploy my demo template, and I will show you how this looks like before. So this is my demo template. It's super simple. It only creates one resource, at least that's how it looks like. It references the VPC 2 zone module that I just uploaded and registered, and it sets the class B to 42. So you can enter whatever you wish here unless it's a number between 0 and 255. So that's what we specified in the parameter section. So let me do that. Let me create a stack, and I will do this using the UI here quickly. So we'll upload the template file. And I will select the demo template. And now the usual CloudFormation steps are needed. So we click through all of that. We acknowledge all those things. And then it is started. It will provision our resources. And now it gets interesting because if you look at the actual resources that are provisioned, you might be surprised what happens. So it takes us some time here. CloudFormation just figures out all those modules. And the funny thing is that what they do is they kind of extract all those modules and expand them into the main template. So that's all what they do. And they do this in a very crazy way. So it's still work in progress. So what's going on here? It's okay. Now it gets started. We are starting with the VPC. And as you can see, the logical ID looks very confusing. And what they do is they actually prefix, like when they merge all those resources from the modules into the like top level template, they prefix the logical ID with the logical ID of the module. So in this case, the module logical ID is VPC and the logical ID of the resource is VPC as well. That's why it's now called VPC. And this is very error prone. I mean, if you create a resource in your main template that has the logical ID VPC, then we get into issues because then there's kind of a collision in logical IDs. So I'm not very happy with that approach. So not sure why they merged the logical IDs in that way. But that's what CloudFormation does. And this is also how you would reference those resources. So basically in your main template, you can reference something that doesn't exist in the main template. You can basically reference into the modules by creating a logical ID based on the module's logical ID, append the logical ID of the resource, and that's it. And if you have nested modules, then this goes on like the chain goes on. And this is completely mad in my opinion, but that's how it is. So as you can see, it's working. It creates all kinds of resources here, subnets and stuff like this. This is great. So that's what we actually expected from this tool. What I haven't expected when I used it the first time is the way it deals with logical IDs. By the way, the same happens with outputs. So the outputs are also merged together in this kind of crazy way. But okay, that's something we can live with. Just keep that in mind when you create your logical IDs to not kind of interfere with the namespace of the modules. All right, so this thing is now completed. All the resources are there, so we can now use this VPC. Great. So modules are working, so that's actually the good news. But now let's look into the bad news. So as I promised in the beginning, I will talk about what CloudFormation Modules is about, the good parts and also the bad parts. So the good part actually is it works as expected, but now we will talk about the bad parts. And this is actually a very long list, so I'm very sorry for that, but it really has so many limitations that I really find it hard to make anything useful out of it. So first, parameters are not validated. So in a CloudFormation parameter, you can specify, for example, that this has to be a string with min length and max length. This number has to be between min and max. You can specify regular expressions. You can say these are the allowed values. So all kinds of validation or like configuration can be made. A module ignores all those information completely. So if you pass in something that's not valid, it will still work. I mean, that's kind of not so cool. Import value is not going to work inside a module. So you cannot use the import value function in a module. You can also not export an output in your module. It's not possible. If you want to reference a resource inside a module, so the logic that I just demonstrated you applies. So you ref the module ID and expand the logical ID of the resource. Same works for if you want to get an attribute. So this is, I mean, I don't think that this is a good approach because there is the potential of collisions within the logical IDs because you can create the same logical ID here and then it will kind of blow up. Next part, you cannot create a CloudFormation stack inside a module. So basically nested stacks are not supported in modules. Also stack sets are not supported. That might not be a big problem. Keep in mind that you can only nest up to 3 levels deep with modules. And what actually is more or less the bummer here is that you have to register the module in each account and each region. So imagine you're working in an enterprise, and that's one of the use cases that AWS kind of has in mind when they talk to us about modules. Yeah, that's a good tool for enterprises where the cloud excellence, how center of excellence can kind of distribute, this is how we want to create a VPC to the whole organization. And I really want to see how this works because in each account, in each region, you have to then deploy this module. And if you want to create a new version of the module, you do the same thing again. So I don't know. This is kind of a weird approach as far as I understand. It is possible to do it nowadays since a couple of days with stack sets, and because in CloudFormation you can now create the resource, the registration resource to register the module in the registry. But I mean, it would be super cool if this would just integrate into the organization. So you could just say, okay, share this module with my org or share this module publicly. That would be even cooler, for example, for people like us who want to distribute this to all the people. But that's not possible. It's super private within account regions. So keep that in mind. The management overhead is not or is quite significant. All right, so what is not working as well? Transforms or macros are not supported. And the most, I think, popular one is the serverless application model transform. So it's not working inside a module, cannot use it. The same applies to the transform function, which includes the AWS include. So you cannot include other files inside such a module, not possible. Another pitfall where I was running into when I was trying to create kind of a serverless example here, it kind of stopped working when I used the AWS CloudFormation package command, which usually turns relative paths into S3 URLs and uploads the file. And this does not go into a module. So AWS CloudFormation package doesn't know about the content of the module, because this whole merging together is only done as soon as you create the stack. So the tooling doesn't know about it. And that's why they don't upload or turn relative paths inside a module into an S3 URL. So it's not working. And I think this kind of eliminates all the serverless use cases. So you cannot do anything useful with modules in the serverless space. So that's also kind of bad news. So yeah, that's kind of the summary here. I'm not using CloudFormation modules, and I'm not going to use CloudFormation modules in the next or in the near term, because of all those limitations that I just talked to you. And if you are interested in a video about our CloudFormation templates or the CloudFormation modules that we provide, then I'm happy to talk about that and give you some demos and show you a little bit how it works. So if this could be an interesting topic for you, let us know. You can write a comment in the community. You can send us an email in reply to the newsletter. Do whatever is the easiest way for you to get in touch with us. I would really love to talk about all of those topics. So I'm just looking for your input in what's most relevant. All right. So let's close this video. So I think I explained you everything that is important about CloudFormation modules. So if you have any questions around this topic or other topics, community.cloudonaut.io is exactly the place where you could ask those questions. So there's a private discussion forum for Cloudonaut Plus subscribers. So if you see the list of forums, click on the Cloudonaut Plus forum and you can ask your questions, and only people within the community, within the private Cloudonaut Plus community will see it, and we will answer your questions, or other people from the community will join in and provide their advice as well. So thank you very much for watching. Don't forget to like this video if you learned something new. Your feedback helps us to produce relevant videos. You can reach us via Twitter, email. You will find all the details in the video description below. So we are back in 1 week. Thanks for your support. Bye.